Now let's solve this question here. There are 8 swimmers in a competition where the top 3 swimmers advance. In how many ways can 3 swimmers advance? Look at this question here. Here, it didn't tell me that I want were the top first, second, and third. Eventually, I want the order. The top 3 swimmers. The first 3 who reach or who finished first. So the order here is not important. So I will use the combination. I will say here I have 8. Here I have 3. So I will say here now 8 factorial, since it is n factorial over r factorial times n minus r factorial. So r factorial, which is this is r, it's 3 factorial times 8 minus 3 factorial. And we said if you want to solve it here, you can say it is 8 times 7 times 6 times 5 factorial over 3 times 2 times 1 times 8 minus 3, which is 5 factorial. Then I can say 8 times 7, which is 42 ways to order them. Is it clear?
Yes.
Yeah.
So this is now for combination. Now, in this problem here, I want to determine whether I will use permutation or combination. From the word problem, I must know, shall I use permutation or combination? How? I will decide. If the order is important, it is permutation. If the order is not important, I will use the combination. Look at problem 5 here. For each situation, determine whether you should use permutation or combination. What is your answer to each question? A chemistry teacher divides his class into 8 groups. Each group submits one drawing of the molecular structure of water. He will select 4 of the drawings to display. In how many different ways can he select the drawings? Here, we have 8 groups. Each group submits one drawing. Okay, now he will select 4 from the 8 groups. I want now to ask myself, shall I use permutation or combination?
Combination.
Combination.
Okay, why combination?
Because the order is not important here. He will choose any 4.
Yeah, he will not say first, second, or third. He choose any 4 from the drawings. So I will use the combination. Thank you. Here I have 8 groups, and he will select 4 from them. So 8 factorial over 4 factorial times 4 factorial. 8 times 7, 6, 5, 4 factorial over 4 factorial times 4, 3, 2, and 1. So 5 times 7, 30 times 2, we have 70 ways. Done? Is it clear? So here,
Yes.
he didn't tell me I will choose, or the teacher will choose the first, second, and third. He will choose any 4. So I will use the combination. Now here, You will draw winners from a total of 25 tickets in a raffle. The first ticket wins $100. The second ticket wins $50. And the third ticket wins $10. In how many different ways can you draw the 3 winning tickets? Here I have 25. I will put first, second, and third. So shall I use, before that, is the order important here or no?
Yeah.
It's important.
Yeah, it's important. So I will use the permutation. Here I have 25 tickets. I will use 3 from them. So I will say 25 over 25 minus 3, which is a 22 factorial. So I have 25 times 24 times 23 times 22 factorial over 22 factorial. Then the answer is the multiplication of 25 times 24 times 23, which is
13,800.
800 ways. Yeah. Thank you. Let's have another question now. For each situation, determine whether to use a permutation or combination, then solve the problem. Number 39. How many different teams of 11 players can be chosen from a soccer team of 16? I have 16. I want to choose 11 players. Is the order important here?
No, it's not important.
It's not important. Exactly. So, number 39, I will use the combination of 16 taken 11. I will not say 11 take 16, okay, because I cannot choose 16 boys as an example from 11. So the greater number, I will put it first, and the small number, I will put it at the second year. So here I will say 16 factorial over what?
11
factorial multiplied by 16 minus 11 factorial.
Exactly. So I will say it now. 16 times 15 times 14 times 13 times 12 times 11 factorial over 11 factorial times 5 factorial. (24) times 14 times 13. Let's see the answer here. It is 4,368 ways. This is for number 39. Let's solve now number 40. Suppose you find 7 equally useful articles related to the topic of the research paper. In how many ways can you choose 5 articles to read?
So it's combination.
Yeah, the order is not important.
Yeah, the order here is not important. Then tell me I want to choose first, second. They are equally, I want to choose any from them. So I will use the combination. What are the numbers here? I have 7 and 5. So I have the number of combinations of 7 taken 5. Yes, Raghat, continue. Here I will say 7 factorial over Raghat.
5 factorial.
Yeah.
times 7 minus 5 factorial.
So it is 7 times 6 times 5 factorial over 5 factorial times 2. So 42 over 2, which is 21 ways. So I have 21 ways to choose 7 or 5 articles from 7. Do you have any question?
No.
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 Number 41 here now. A salad bar offers 8 choices of toppings for a salad. In how many ways can you choose for toppings?
It's also a
It's
combination.
It's also combination, yeah. Combination of 8 taken
And 4.
4. Yes, Habiba, continue.
8 factorial over
Sorry.
over 4 factorial times 8 minus 4 factorial.
Yeah, thank you. So I would say 8 times 7 times 6 times 5 times 4 factorial over 4 factorial times 8 minus 4 factorial, which is 4 times 3 times 2 times 1. This one, this one here, and this one too. So 14 times 5, only you can say 10 times 7, which is 70 ways. Do you have any question?
No, thank you.
Oh,
Let's do now this question here. Assume A and B are positive integers. Determine whether each statement is true or false. If it is true, explain why. If it is false, give a counter example. Let's start now with the first one. 42. A factorial plus B factorial. Is it equal? B factorial plus A factorial. So here I will write like this, 42. A factorial plus B factorial. Does it equal B factorial plus A factorial? To see if it is
yeah, it
equal or
should.
wrong,
Because addition
I
is
will
coming.
put a numbers. A factorial, let's make A is 3, B is 4. So 3 factorial plus 4 factorial, is it equal 4 factorial plus 3 factorial?
Yeah,
Yes.
Yes,
Yes.
why?
Because addition is coming.
addition is commutative.
So because of the commutative property of addition. If I change the order, it doesn't matter. So because of the commutative property. Now, number 43. A factorial times B factorial C factorial equals A factorial B factorial times C factorial. Is it like this?
Yes, it's true.
Yeah, it's associative property. Yeah,
It is an associative property, so it is same. It's equal. So yes, because of addition. Now, number 44. In number 44 here, a plus b factorial equals a factorial plus b factorial. It is like
Yes,
distributive
it's true.
property. Let's see if it is work or no. We assume that a is 3, b is 4. So 3 plus 4 factorial, is it equal to 3 factorial plus 4 factorial?
No.
Yeah,
Let's see. 3 plus 4
it is.
is 7. What is 7 factorial?
50,
Let's write it
40.
here in calculator. 7 factorial is 5,000. Or before that, let's write it here as 7 factorial, which is 5,040. Let's see now. 3 factorial is 6. And 4 factorial,
24.
it is 24. So the summation is 30. Are they equal?
No.
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 So they are not equal. So the associative, the commutative can work, but the distributive cannot. Is it clear, the first three?
Yes.
Yeah.
Let's see now number 45. Does a times b factorial equals a factorial times b factorial? Like 3 times 4 factorial. Is it equal 3 factorial times 4 factorial?
No, it's not.
3 factorial, we said it is 6. And 4 factorial
24.
is 24. If you multiply them, you must get 144. Let's see now. 3 times 4, it's 12. 12 factorial is a big number. So are they equal?
No.
No.
No, they're not.
So false. They are not equal. Now, number 46 here. A factorial factorial. Is it equal a factorial squared? That's mean if I take number 3 as an example, say like 3 factorial factorial. Is it equal 3 factorial squared? 3 factorial is what? 3 times 2, which is 6. So here I first solve the number inside the bracket. It is 6 factorial. And 6 factorial, which is 6 times 5,
It's 720.
720. Here now, 3 factorial is a 6. Is 6 squared, which is 36, equals 720?
No.
No.
No. Here I took 3 factorial, then I square it. I get, this is 6 squared, okay? It's not 62. Is it equal 6 factorial? It's also false. Now let's do number 47 here. A factorial raised to the power b. Is it equal a times b raised to the power b factorial? Like we said that a is 3 B is 4. We assume that A is 3, B is 4. So 3 factorial to the power 4. Is it equal 3 raised to the power 4 factorial?
No, it's not.
3 factorial is what? It is 6. 6 to the power 4 is equal 3 to the power 4 factorial, 4 factorial, which is 24. Now, I will say check. If 6 to the power 4 equals 3 to the power 24, let's see now. 6 to the power 4, 1296. And 3 to the power 24, it is a very big number. It is 2 times 8 times 10 to the power 11. Are they equal?
No.
No.
No. They are not equal. So only the commutative and the associative property can work in the factorial. Do you have any question?
No.
No.
No, teacher. Thank you.
Yeah, welcome. Our lesson stop here. Tomorrow we will talk about probability. We will talk about the experimental